Hi everyone, welcome to class today. Final class of the semester live. So, hope you all are doing good. We have a pretty simple objective today, and that is for me to answer your questions and to review for the exam. And in addition to that, I have a bunch of other stuff I can talk about. That is from that video that I want you to watch on Wednesday, optionally. But I do want to bring some things up today because I have a feeling that there won't be that many questions. But maybe prove me wrong and I'll answer all the questions you want. So yes, yeah, I got a haircut, a little bit too short, but yeah. Okay, so yeah, let's just. Oh yeah, talking about the extra credit. There is some person here that I don't know if it was from this class or not, that redeemed extra credit. Might have been from 202 class. They have not identified themselves to me. Their name is Chaden81. So if you are here, I want you to claim because I don't know who you are. And then we also have the other person, the Fox LOL, who has claimed extra credit, but they also haven't contacted me. So if you don't contact me, I have no idea who you are. So you have to tell me who you are. And it's especially important for the people that are redeeming extra credit right now. So those of you that just redeemed, make sure that you tell me who you are, as in like your Canvas name, Twitch name, and class. So make sure you do that. Don't forget. Like, do that right now if you want. Send me a Discord message or send me a Canvas message or send me an email. But don't forget to do that because I won't be able to remind you next class because there's no next class. So if you don't do it, I don't know who you are. You don't get the points. So just go ahead and do that right now if you want, just so you don't forget. And I will give you all the points after 7 p.m. So check in the evening to make sure that you've gotten the points. So yeah, okay. So I mean, let's start out by just opening the floor because, like I said, I have other stuff I can talk about, but I'd rather answer questions first. So let's just go ahead and see if anyone has any particular questions that you want me to talk about. Otherwise, I can give you a brief overview of the test. In fact, I'll do that if you want. Graphing, can you review graphing? I can review graphing. Is there a particular algorithm that you want me to review from the ones that we did? Like an example of, I don't know, Dijkstra? Okay. Yeah, we can do Dijkstra. All right, so we'll do one Dijkstra then. Minimum span trees would be nice. For minimum span trees, is there one of the two that you want me to go over? Minimum spanning trees. Okay. Well, I guess we'll do prim then, because that one's the one that's closer to Dijkstra, so we kind of knock them both out at once. Okay. So I'll do one example of each of those, at least. Okay. In the meantime, I do have, let me see, final exam. Don't forget that the exam has to be at the class time, so it will be, the designated time is from 6 to 8 that you have to take the test. I'm making it available from 5:30 to 8:30, but I can't go anywhere outside of that really because otherwise you like we're not allowed because we're overlapping exams. So yeah, so just assume that you have 2 hours from 6 to 8, and then you have that extra 30 minutes. You can think of those as in case of an emergency. So I'm looking at the exam right now. The exam for this class is on December 6th. So that is Monday 6 to 8 on Canvas. Same format as the other two. And the exam has 15 questions, of which really it's 13 questions. Because remember, in the beginning you have that academic integrity thing, and then at the end you have the question upload, which allows you to upload any scratch work or additional file uploads. So you only have 13 questions. Those are like actual questions. Of those, you're going to have a depth first search, breadth first search, topological sort, minimum spanning tree, Dijkstra, graph knowledge, adjacency matrix, adjacency list knowledge, algorithm analysis, APL tree, traversals, sorting, of which it could be quick sort, merge sort, heap sort, one of those. But you only have one. And then one recurrence relation. So that's it. That's literally the topic of each question. So there you go. Okay. That is basically the overview of that. I don't think I skipped anything. I'm just looking at a question that I want to change. Okay. Do you want us to draw a scratch mark or scan it? Or, either or is fine, whatever you are more comfortable with and can probably do more efficiently. So if you prefer to do it on hand and then scan it, you can. You can also do paint. I think it's easier to do it on paint because you can copy and paste like the drawing so that you show like the steps. Whereas if you're doing it by hand, you have to redraw it every time or redraw boxes. It just takes longer. So that is my advice. But you can choose either or. That's why there's that final upload at the end of the test, so you can upload anything else you need. And you do have that extra time, so you can have enough time to be able to scan and do whatever you want to do. I think the test should take, if you're really good at the material, you should be able to finish it in about an hour. So you basically have another hour to upload. Now, if it takes you longer, that's fine. You have 2 hours, but you should have plenty of time as long as you remember how to do things and you know how to look up every one of them. Quadratic probing. What is the h of x function for that? Is it like 2x or x squared? It depends on who you ask. It's definitely not 2 to the x though. Or actually, wait, no, x squared. Well, okay. The way you put that is misleading. So normally h of x is your hashing function. And so that is going to be something like 2 of x, whatever. That doesn't matter. When there's a collision there, then you have to feed it to some other sort of function. And what you are feeding in there is the result of h of x. So you're feeding that in. Okay? And so that value, which let's say this is like, I don't know, let's just say this is x mod 10 to make life easy. Let's say that's a table. And let's say the x is equal to 3 or 30, doesn't matter, but let's just say 3. So this means that h of x is going to be equal to 3, right? And so here, and the reason I'm answering this first is because that's a quick answer instead of doing the graph. So here, if there's a collision there, what you want to do is you want to add a certain offset to that. And so this offset here is going to be some variable which you're going to increase as time goes on, but you're going to increase it in a quadratic fashion, right? So like let's just call that variable y. And so y is basically going to increase every time by doubling the size of it. And so that would be a 2, right? So every time you update it, then you're going to take it times 2. Okay, so really think about quadratic hashing in this sort of format. Okay, that you have this offset, and that offset is going to go like that. And that's assuming that you are actually, it goes like that as long as you refeed it the same value over and over again. But if y is just going to be increasing like numerically like 1, 2, 3, then you could do y squared like that. Okay, so it just depends on how you define it, but it should be increasing in a quadratic fashion, so that it's quadratic. And if it was linear, then it would just be a linear thing, like, you know, y plus 1 and so on. Okay, so yeah. Using tablet buttons to do the test, yes, the best way is probably like this stuff. Like you have a tablet, you can, well, in my case, yeah, tablet and then making a PDF is fast. But if you can, at least if you can stream it, then you can screen capture it and then put it in the test, so you don't have to email yourself the PDF. But either or. But anyways, that's my answer to that. So Dijkstra. So for Dijkstra, let's just draw a small graph so we don't spend too long on this unnecessarily, like repetitive. It doesn't get repetitive. Okay, you know what's easier? Copy paste. Okay, so let us say that we have the following graph. Maybe one more. Okay, and so this is our starting node, and let's just name the nodes A, B, C, D, and E, and let's put some weight. So let's just say 2, 3, 1, 1, 5. Okay, so when you're doing your Dijkstra for this, the first thing you should do is draw the table. And we'll do Dijkstra and shortest minimum spanning tree with it. So for the Dijkstra, you have the vertex, you have a key, you have a parent, and you have a visited array. The important thing here to remember is that this visited array is whenever you go and run the process of Dijkstra on the node, and that you only want to do that once per vertex. So you go ahead and you list all your vertices here. And then you start out by assuming that the key value is infinity, which I'm going to leave as blank. The parent of the starting node has no parent, and the other ones are unknown. And then you mark the starting node as visited, but nothing else is visited. Okay, so everything else is set to false per se, or blank. And so ultimately, what you want to do per vertices or vertex is you want to check all the edges that are outgoing from that vertex. And if it's an undirected graph like it is here, then you just consider all edges. If it was directed, you would just put the ones with the arrow coming out. And so there's only really one edge coming there. So that means that you're going to compare what the current key value of A is with the weight that S has, which you can just initialize to 0 because that's your starting point, plus the weight, the length of the edge. So something in this case of S key value, which is 0, plus the weight going from vertex S to vertex A, that is equal to 2. So 0 plus 2 is 2. And so now you're going to compare this with the current value of A key, which is infinity right now. And so you say, is 2 less than infinity? And if it is, then you're going to go ahead and replace the weight or the value of key with that. And you're also going to set the parent of A to be whatever you are coming from, which is in this case S. And so basically you're going to put an S here, and you're going to put a weight of 2 there, and that's it. So the next step you do, and this is what you have to do every time you finish one vertex, is you have to look at all of the remaining vertices that are not visited, so these 4, and pick the one with the smallest weight to go on. In this case, these are all have infinity, but this one has a value of 2. Therefore, this is the smallest one. And so you go ahead and you pick that to work on. So the first thing you do is you're going to mark that as visited. And so now you're going to look at all the edges coming out of vertex A. In this case, we have 1, 2, 3, and technically 4 edges that we have to look at. However, as you can notice, we already colored that edge blue, and now we're coloring it red. What that's saying is we're trying to check the same edge twice. The reason we don't do that is because when we look at the edge going from A to S, we can see that S is already marked as visited, and so we don't want to verify any edges that are already marked as visited for the destination vertex. So we don't do anything for that. So really we only have 3 edges to look at. Edges A to B, edges A to D, and then edge A to C. And the weight of those edges are 3, 1, 4. And so what we want to do is we want to take, again, the same operation that we have here. So we're going to take the value of, in this case, we're working with A. So now this is A. And we take the value of that key, which is 2. And we're going to basically add one of these there. So let's start out with the first one. So in this case, we're going to add the weight of the edge going from A to B. That is a weight of 3, so we do 2 plus 3. 2 plus 3 is equal to 5. We compare that with infinity. Of course, 5 is smaller than infinity. So we have found a new shorter path to node B, which in this case is better than no path, actually. And so we are doing what's known as a relaxation. So we're changing that infinity to be a value of 5 and setting the parent to be the one we're working with, which is A. And we're going to repeat that same step for the other 2 vertices. So this one's going to be 3, and this one's going to be also 3 for C. And set also the source to be A. Okay, and that basically concludes us working with vertex A. We again repeat this same system. We look at the smallest one. In this case, though, we have 2 vertices that have the same exact weight. At that case, you just pick one of the 2. This does indicate the possibility of there being more than one solution to this graph. And I wish I could drink water, but I don't have water and it's too far away for me to graph. It's like back there. So sad emoji. Okay. Let's just pick C then for this to work. So in this case, we are going to look at C. And so C has 2 edges, but the edge going from C to A is not an edge that we care about because A is marked as visited. So really we're only looking at this edge from C to D. Now C to D means we have to compare the key value of C plus the weight of the edge going from C to D. And we have to see if that is smaller than what is currently in the weight in the key of D. These values are currently 3 plus C to D, which is 4. Is that less than the current value of D, which is 3? The answer, it is not, because 7 is not equal, or sorry, not less than 3, right? So because that does not return true, there is no update. So no update happens there, and we are technically now done working with C. Oh, let's see. Okay, so now we pick the other three because it's still the smallest now, and so now we're gonna work with not the other C, but the other three, which is D. Okay, so looking at D, there is 3 edges going out of it: this edge, and this edge. But the 2 of the 3 edges are going to vertices we already visited, so they're not going to be relevant to us. That's the only one that we want. In this case, E has infinity, so anything is better than infinity. So 3 plus 5 is going to be 8. So that is a new shortest path with a source of vertex D. And now we're done. So now we pick the next smallest vertex, which is this one. And so B has 2 edges going out of it. In this case, it is the edge going from B to 3, which we don't care about because it's already visited, and B to E, which is a new edge. So to do that one, we do the same computation again. So we say B key plus the weight of B going to E, is that less than what E key currently contains? B dot key has currently a 5, which is the fastest way to get to B essentially, plus 1, which is the weight from B to E. That's equal to 6. So is 6 less than what currently is an E, which is an 8? In this case, that is true. So what we are going to do is we're going to update E dot key with this new, basically this new data here. So we're going to put a 6 there, and that's going to get updated. And similarly, E dot parent is going to get updated with this value. Okay, so 6 and B. And that 6 looks weird. Draw another one. Okay, and now we're done with B. Whenever we have one node left, we don't need to do it, but suppose we did, whatever, you'd see that there is no edges to update because everything is marked as visited. So yeah, we're good to go. All right, and so now that you have the shortest path, what you're saying is you know how to get the fastest to anywhere in this graph as long as you start from S. If you start from anywhere else, then you can't confirm that unless your destination was S. Okay? So if I want to find the shortest path between S and E, what I do is I look at my graph, or my chart, I mean, and I see what the source of this vertex is, what the parent is. That's a B. First of all, I know how long it's going to take to get from S to E because I see it's a 6 here. But also, I can see how to get there. It says go to B first. So I go ahead and do that. Let me just go to B here real fast. Okay, now I'm at B. Now what? Well, looking at B here, it says go to A. So we go to A. And then from A, it says go to S. And there you go. That's going to be your shortest path between the 2 vertices there. So that. Okay? That's Dijkstra right there. So, yeah. Now, minimum spanning tree is the same concept as Dijkstra. The only difference is that when you're doing the comparison between what you currently have at the vertex key versus what you're comparing with the previous one or the edge, you don't add the previous value. You only add the current value of the weight. And by that, what I mean, I'll show it in a second actually. I'm just trying to delete all the color. You use the same chart as you do with Dijkstra. Okay, and so basically what you do is you just run the same algorithm but do not make the addition. So in this case, the first step is going to be the same, so you're still going to put a 2 here, parent's going to be S, and then from there you're going to visit that, and then you're going to go ahead and look at the 3 edges here, but not this edge because it's already visited. So the difference here being that in the past, if I want to update B, I would have set 2 plus 3, and I would have set a 5 here. But in this case, you don't do this 2 plus part. You're just looking at the actual weights and seeing if these weights are smaller than one you currently have. In this case, they're all infinity, so all the weights are smaller, so we'll be updating them. So this will have a 3 with a parent of A. This will have a 1 with a parent of A, and this will also have a 1 with a parent of A. And that accounts for the 3 purple edges that we just saw. Okay? From there, we pick the smallest one. In this case, we again have a situation where we got to decide between those two. This could signify that there could be more than one solution to this graph. It may or may not, though. We'll see. So let's go ahead and pick one of the two. So let's pick C. So now when we're at C, let's mark that as visited. And so let's look at the edges going out from C. So we have 2, but one of them is going to a vertex we already visited, so we don't need to do that one. So we just got to do the one from C to D. Now D already has something there. In the past, we would have said, you know, the weight of C plus the weight of the edge. The weight of C would have been 3 in the past, and then we'd have said 3 plus 4, which we got in a 7. I put an 8 before. I guess that should have been a 7, or maybe I did have a 7. I just don't remember. But the point is that in this case, you don't do that. All you do is you just look at the number 4, and so this 4 is not smaller than a 1, so there is no update done there. Okay. So in this case, we're done with C. So now pick the other one weight vertex, which is D. And so D has 3 edges going out of it, of which the ones to A and C are already marked as visited. So we don't deal with those. We ignore them. We only have one to look at, which is to E. In this case, however, going to E is going to be just put a 5 here because it's infinity currently. And you want to put as a source the D. Yeah, that's all you do there. Okay. Finally, we go to B because it has a weight of 3. And so looking at B, we can see that there are 2 edges. We have this one and we have this one, but we don't care about that one going from B to A because that one is already visited. So we only care about that one, B to E. And so we can see that the 1 is smaller than the 5. So this is relaxation step. We're going to take that 1 and convert it, 5 and convert it to a 1 and change that source to be, or parent to be B instead of D. And there we go. So now if we want to draw the resulting minimum spanning tree graph, all we got to do is connect the lines. So you'll see it here in a second. So let's just oh, we killed one of the nodes. Hold on. So we want to draw the resulting minimum spanning tree. What you gotta look at are these pairs right here. And so basically saying draw a line from E to B, and put a weight of 1 there. Draw a line. I'm going right to left now for some reason. Go draw a line from D to A, all right, D to A, and put a weight of 1. Draw a line from C to A and put a weight of 1. Draw a line from B to A and put a weight of 3. And draw a line from A to S and put a weight of 2. And there you go. That's your minimum spanning tree, which is indeed correct. Okay? So that is a quick review of minimum spanning trees and Dijkstra. Essentially, the same algorithm, just one difference being that addition. So as long as you remember that, as long as you remember one of the algorithms and then remember the difference, then you got them both. So easier said than done, but it's a matter of practice. That's all it is. Okay? So, yeah. What else? Here. How do you want us to show it on a test if we can't use the table? You can use the table. You would just show the table multiple steps. Unless you actually don't want to use the table. I don't know if you're asking like if you don't want to use it. Any coding questions on this exam? I don't think so. When I went over the exam at the beginning, I don't actually recall seeing any coding questions. The table is nice because you don't have to draw as much. You have to draw for other algorithms. You can choose to not use the table for the MST. If you choose not to use the table for the MST, then you have to draw the equivalent of that, which is like where you, for each of the vertices, you have to draw the same data. So you have to draw the running weight to it. So like let's say 2, S. Okay, and then somehow you tell me whether something is visited or not. So I don't know, you can put a check mark or an X, but put a key or something, or V for visited or something. So you have to tell me that information still. You can't just draw the graph like in multiple steps and be like it's done. Are you going to release the answers to the exam too? No, but you can ask the TAs and they can go over a question with you if you want to see like individual question answers. I'll be back in a second. I'm gonna go get some water. I'll leave you with the one last intro sound. There we go. Not like a half-empty bottle and another half-empty bottle. Again, another reminder that there is extra credit. Oh yeah, I did add one more tier of extra credit. That's like half points, so like 50 points instead of 100. Or for you guys, it's actually 100 versus 200 for 1,400 points, I think. So you can maximize your point usage. Cyber Monday deal or something. I don't know. Oh, you should be able to see it. I don't know. Let me check that. Oh, I have no idea. That's a TA question, not for me. But I'm warning you. You all can expect the final grade to be on the last day. So like probably like the Tuesday of we have just like so much stuff to grade and do stuff. So the grades are due on the 14th at 2 p.m. Or sorry, not 5 p.m. So my hope is to finish on Monday by midnight, so that I'm like submit your grade. So at some point on Canvas, you can see the grade ahead of time, like on the 11th or 12th. So yeah. Now let me see the deal with exam 2 versus exam 1. What's wrong with that? Hold on. So I'm gonna open up exam 1 and I'm gonna open up exam 2 so that I can see if there's something wrong with it that's like hiding it. I see what the issue is. Okay, hold on a second. I see the issue, but I don't see an option to change it. Okay, you should be able to see them now. Try it. I don't know why that got switched around. And I think TA writes comments when you get a question wrong too. So thank you for letting me know about that. Well, that's why you do the extra credit. It's like insurance. It's like you insure yourself for the dark times. Thank you for catching that. I'm gonna have to check, make sure that the same setting is set for the final, so that when the TA grades the final, you get a chance to at least catch the grade. See if there's nothing wrong. Let me make sure that's also set for the final. Okay, so it's also set for the final the same way. So you'll be able to see it too. That's funny. Okay. More questions, Mike, you can come my way. In the meantime, I'll just show you some NP stuff. But please, I'd rather do review of questions, so if anything comes in. How will you curve? When the final grades are in on Canvas, I will see the grade and I will compare it, and then I'll see the general distribution of the class as a bell curve, and then kind of see how off we're from that, and then make an adjustment. Also, if you do extra credits, then I will, and you're closer to the next grade, then that will also take an effect. And finally, if anybody did like things like the YouTube timestamps or submitting notes and things like that, I will add those in also then, since they don't show up before then. The image is the completion points. I believe it's 50 points or 20 points. It's pretty insignificant when it comes to the actual grade, because it's just homework points. It's like a worksheet basically in terms of points, I think. So this stuff is from the video that I recommend you watch on Wednesday. The only thing I want to really mention from this stuff you learn in automata class, so don't really want to or need to talk about that. 456, yep. Algorithm analysis you will learn in 477 in more in detail. This is nice to talk about though. The trifor symbol, that's probably because of heap sort. These are some of the algorithms that we learned in this class: bubble sort, depth first search, breadth first search, quick sorts, lots of sorts actually. Actually, why is bubble sort there? Now that I think about this, that's probably making a joke or something. Dijkstra, merge sort. I think these are the ones that students remembered. So one of the things that I want you to notice, and I did bring it up already, is that some of the algorithms that we looked at have some similarities in them, and that's because there are only so many ways that you can create algorithms. Like when you look at it, it's like how you can, most movies can become like the Joseph Campbell's Journey. It's kind of like the same thing with algorithms. Like you can kind of just classify them all into certain tiers. And it's like, this stuff will, again, they'll spend like a month on this on 477, but it's nice to think about it now, just, while the algorithms are still fresh in your head. So I already talked about dynamic programming and how Dijkstra is all about that because it remembers where it's been. And in a way, a little bit, the Prim's algorithm is kind of like that actually too. But anytime that you have a recursive algorithm and you actually make it iterative, and you remember something, so you don't have to recall, or actually even if you leave it recursive, but you use like built-in code to like a built-in system that remembers function calls, so it doesn't call them multiple times, like Python does with mnemonization. That's dynamic programming because you're remembering what you've done in the past, so you don't do it again. It's the concept of memory, memorization, as I have it there. Liebenstein is an algorithm that you're going to learn in 477, which does the same thing, and it's a really cool algorithm in shortest path, and yeah, I use it a lot. I don't code it, I just use a library function. Import Liebenstein, or import edit distance, and then like run a line, but it's cool. So yeah, greedy algorithms are the ones you usually learn first. Things like DFS and traversals are greedy. There's also divide and conquer. That's another one that you learn back in, or at least you learn the idea of it in 135 and 202, like those basic idea of like breaking a problem into smaller steps. That's a pretty standard thing to do just in general in life, I guess. Backtracking is kind of hard to think about. We technically did it with DFS. Also, when you think about when you finish Dijkstra or minimum spending trees, that's a better one. When you're building the graph, you're technically backtracking. The idea of like going back to your pointer. So that's another system. Not really focused this semester on that one, so that's okay if you don't get it. The randomized one is kind of cool when you think about it. Like that's the whole idea with the pivot that we had in Quicksort, where like if you think about it, I said, you know, the best way to pick the pivot in Quicksort, it would be to pick something that is like right in the middle of your data. But figuring out what the middle of your data is takes too long. It would slow the algorithm down to like n squared basically, in all cases. And so the best thing to do is just to pick a pivot at random, and random distribution is like awesome because it will actually kind of give you something in the middle usually. So this whole idea of randomized algorithms goes way beyond that. But that's at least one example you saw in this class, and you probably remember that now. A year from now, when you take 477, if you don't take it immediately, you're probably gonna not you not remember how to do the pivot, probably Quicksort. I mean, I hope you do, but let's be honest here. It's a lot of content that this class has. Heuristics, I don't think we did anything in this class, but those are educated guesses. Those are things that allow us to solve problems quicker than what the time complexity of a problem would be. But for that, you really have to understand NP completeness. Let's see if there's any questions about other stuff. How do we submit notes? You submit them by making a PDF and submitting them to me, but email or Discord. But the big catch with this, actually I prefer email for that because it might be a big file. You won't be able to send it to Discord. The big catch is they have to be legible, they have to be good, they will be judged, and then they will be released to your peers. I hope you all notice, but like I have a whole database of notes on Canvas from past semesters for students to look at and review if they wanted to study. So that's a study guide-esque. So yes, you're donating them to the common good of open source. So just FYI that you're doing that if you submit them to me. And those don't have a defined extra credit points. Like I said, again, if you're like a 90, you know, if like you're like 0.2 away from the next grade tier, then you know it'll get bumped. Tonight, actually, I believe that's the deadline that I set for everybody was tonight. Okay. Cheers. But you can try. I don't know if it'll work, but you can try to redo that. This P versus NP, you know, I was talking about it the other day. The only thing I really want you to know for like this class and for the test and everything is whether this whole P versus NP situation, right? So pretty much all the algorithms that we looked at this semester are algorithms that you can do in decent amount of time, which we call polynomial time. Polynomial time means polynomials for math. There's an exponent, there's a base, and there's an exponent, and that's it. So like, if that exponent is 5, that's kind of slow, but at least it's a fixed value. So like, if you have 100 things, it's 100 to the 5th power, right? Not as great, but you know, if you want something fast, then that's when you have your n log n or linear time. Polynomial time still is decent for speed. It's like, okay, I can live with this. Not all algorithms out there are polynomial time. Some of them you can't define with a polynomial, even if you put like 100 to the 1 million power, or sorry, n to the 1 million power. Like, it's not. It's still something that just grows beyond that. You can't bind it or bound it by that. We call those the non-deterministic in polynomial time algorithms, which means that you can't find an answer in polynomial time. Some people call it non-polynomial. It's technically not the right terminology for NP. It means non-deterministic in polynomial time, which means and the Turing machine part is because you can't make a Turing machine that can do it in polynomial time. So it's just simply saying there's no solution, but that is kind of still in the air. So that would be n to the power of n. That would be an exponential time algorithm technically. So that would not be polynomial, because polynomial means that it has to be fixed. So that exponent has to be fixed. In your case, it's growing as the number of n grows, the exponent grows, and so that is non-polynomial what you're saying. So Yeah, so NP is a non-deterministic in polynomial time, which means you can't solve the problem with a polynomial time algorithm. Now that's a big statement, saying whether something can be or not be solved in a given amount of time. The only time that we kind of looked at that was with sorting, right? I showed you like this sort of pseudo proof that n log n was the fastest that you could ever sort something with comparison based, which is true and accepted amongst everybody. Can you get around that? Sure, you can do parallel programming and like, you know, do things technically faster, but it's not in like a sequential manner. This is kind of saying the same thing. In a sequential manner, you can't solve this problem in polynomial time. And this is something that the majority of people agree with, but it's not proven, which means that tomorrow it could change. So if somebody asks you whether P or NP is equal to each other, such as like in the exam, then the answer is that there is no answer. The majority of people say that they think that it's true, that they're not equal. Yeah, like, well, false. I guess the way I asked the question is false. They're not equal. Basically, it's not a question of like how we found the algorithm, but like, does an algorithm exist that could solve it? And so that's kind of really where you stand. Okay? That's going to be what NP is. And so within the NP category, there is NP hard problems, NP complete problems, and you know, you can go and watch my video on that to kind of know more about them and what the categories are and what they mean. But here's just a quick little visualization of what they look like. So in this class, in 302, we have focused basically on the little circle at the bottom right here. That little circle is this class. That's what we've spent an entire semester on, is this circle. I should have actually scrolled down so you could see that way, so I could then have that effect of zooming out and showing you the bigger picture, right? But oh well, missed opportunity. But yeah, so this is this class. This around here is probably about 477. And then this is if you take some specialized class, I guess. Or just not something that you look at. Because it's not that interesting, except for some cases. Like you will see the halting problem when you take automata and algorithms. But yeah, so the real question is whether these circles are real or if it's just one big circle and the lines are made up by us because we can't think of a solution. That's the P versus NP dilemma, basically. Okay, so I was gonna remember. I forgot what the we have these NP intermediate made up thing. Yeah, don't worry about that. But yeah, ignore the purple cloud. So basically, yeah, we don't know if this circle exists or if it's part of the bigger circle. So is this a separate circle than this? Is what we don't know. We also are not for sure, but we do think that even if these two circles were the same, we do think that there are some problems here that are not shared with this. And then we also think that there are problems that are shared amongst these. So there's different categories, different things. The way that we basically link them together is when we come up with a problem that we know is in one of these circles, and then what we do is we write a little proof that converts another problem, like a new problem we discover, and converts that into one of the existing problems in one of these categories, okay? So like, for example, if I ask you, what's the quickest way that I can sort a list? Then you're gonna be like, oh, n log n, you know, as comparison based, right? Okay. What if I hide the way I asked that question? What if I am asking like, oh, I have a bunch of people and I gotta deliver them these documents. You know, I have things in like A, B, C, D, E, F, G order, and what do I do? And so all I'm doing is I'm hiding the fact that this is at the bare bones a simple sorting problem, right? So if you remove all the BS from that, you basically see that it's just a sorting problem, and so it's an n log n problem, right? You can think of the same way when you come up with these new problems. The knapsack problem is all about fitting things in the backpack per se, knapsack, but it applies to any sort of organizational situation where you got a space and you got an object you got to put in there or data and things like that. So that process is what the other day I was talking about, reduction. Okay. Yes. You will learn about P versus NP in 477. So this is all 477 land basically. This is all 477 world. But even in that class, like you're not going to go too hardcore into it, but way more than this class. So you spent a lot of time. You probably have some hard test questions on this stuff. and so on, but not for this class. Okay, so that's really the only thing that that I kind of wanted to bring up. You can like I said, this is like a 1 hour long video you can watch on Wednesday if you're bored on this stuff. So yeah, I recommend you watch that if you want. But I might ask you on a test whether P or NP is equal to each other, just because it scares people. If they don't know the answer and they Google it, they see all these like massive debates online, and they're like, "What do I put on the test?" kind of situation. So you might see that on the test, like as a 1 point question in like a 1 million point test. So it's worthless, but it still kind of freaks people out. Okay. So yeah. Do we have any last questions on the exam? Any review that you want me to go over? Within reason, because I mean we are running shorter on time, so don't ask me to re-explain to you like DFS. That might take. I mean, I can try, but it might take us a lot of time. Half-Life Alyx. That was fun. The only time I played that game was when I did the lecture. I never actually played the game too. The coolest code I done on stream was when I in the two class when I code the linked lists. That's nice. But that's about the limitation in terms of time. I have my dog here with me. So yeah, I will just chill here. I did forget to record, so I will have to download the lecture and upload it to YouTube, or actually I'll just leave it on Twitch and just leave the link for today since there's no new material per se. Oh yeah, I saw those mentioned on Discord. So you don't want to take those classes. Those classes are for the non-CS major. So like if you have a person that has a bachelor's degree in like finance or hospitality or medical school of some sort, they don't know programming, but they have data that they work on their domain to it. And so the class is aimed at those people and how they can learn tools that they can apply so they can do data analytics on their custom data sets. So like medical person may come in and say, well, I have a bunch of these medical data that I want to like graph or look at certain statistical values or do machine learning on, like to predict some value or something, regression. Those are the people that the class targets. What we do is we teach them basic Python, and so they can they can just take what they have from their domain and basically learn enough coding that they can actually run some libraries from like scikit-learn, NumPy, pandas, and whatnot. So that's kind of the limitation. It's cool, but like the first of the course, like 621 is it's 135 and maybe a little bit of 202 because we do a little bit of classes, but like that's it. That's all the classes, and it's all in Python because then we can use the libraries. So it's not going to really benefit as a CS major. If you take the machine learning course, you're going to learn way more in-depth stuff. Or you take the data mining course, so you're going to learn way more in depth because you don't have the limitation of not knowing how to program. For these people, like I have to go like, this is Linux, this is Python, this is a variable, that kind of like very basic because they don't know, and that's okay because again they don't need to know. They don't need to know what Dijkstra is. If they ever need some sort of shortest path, I'll just tell them like, here, this is algorithm. Here's the line of code. Just put this in and put this in, and you're good to go. They don't need to know this because it's not their area. So that's what it's aimed for. It's a master's degree in data analytics. So yeah. But yes, it's all Python. In fact, I have code from that. Yeah, this is like an example of a class. As you can see, it was very simple class that we did. So it's like something you would do like when you're learning classes in 202. exception handling. Here's something interesting. So here's like, you know, matplotlib, open a CSV file, you know, load it, show code on how to like find the average of data, number of rows, finding duplicates, plotting a graph. Does this plot the graph? Let's see. It should plot it. I remember. So like, bam, see? I did a function call to plot this graph. This is literally that. Matplot.plot x and y, where x and y are the lists that contain the x values and the y values. By the way, I could not fix this live on the class, and I feel bad, and I still can't fix it, and I've given up on it. The labels are just overlapping, and like it's just a headache with matplotlib. I told them to Photoshop the labels to fix it. Sad, but yeah. So yeah, that's the kind of stuff you do. I'm fluent in Python. I love Python. I use Python all day. I literally this last week, I was very, very busy coding in Python. I coded like pretty much outside of Thanksgiving dinner. I was coding in Python nonstop. It's all public code actually. It's on Git, so you can see my code. It's not pretty, but again, I just wanted to get it done. You know, Arduinos are cool, but I prefer a Raspberry Pi. The Fox LOL, by the way, if you're here, you need to tell me who you are so you can get extra credit points. You're the other person that has not told me who they are, so I don't know who to give the points to. Between Python and C++, what is easier? I think Python is the easiest and the best language ever. It's just programming is about automating things and making your life easy, right? And Python, I think, is the best one at doing that. Obviously, if you're trying to build something specific, like a big thing, an engine or something, then Python's not the way. But for what I use programming for, Python, I feel, is the ideal scenario. I did do that. As a question is, the sort of message you mentioned, we'll do a tutorial overview of your VS Studio setup. I did do that, but I did that in the Tool 2 class. So it's in the first video of the Tool 2 class, which I do have here. So like, this is a stack. I coded a stack for them and a queue. And so, yeah, I can set breakpoints and everything. So, you know, if I run that, here we're looking at the call stack values. You can see it's uninitialized, and then you can go into each thing and, you know, it's initializing it to a size of 3. Run the constructor. Now it's pushing something in, pushing again, and so on. And you can see the values change. You can see the D has 67. You see the contents of the array as well. This is pretty easy to set up. I have the video. It's just the first video. It takes about 5 minutes once you're used to it. Actually, you could do this in like 2 minutes, but you always have to remember how to get things working. But yeah, once it's set up, it's good to go. But Python's even better than that. I don't need to set up anything for the Python debugger to work. It just works. Again, another reason why Python's nice. Anyways, I lost track of all the chat. I'm trying to catch up, but I lost track of who what were. C# is fine too. It's better than Java, in my opinion, at least. But you get to learn Java in 326. Well, like I said, I am just sitting here chilling for the next 15 minutes, well, 13 minutes. If there's any last minute questions that you have on the exam. Otherwise, we're done for the semester. Like I said, no live stream on Wednesday. You can watch the video if you want, or you can just spend the time studying, do study groups. I don't know. I mean, I would say that when we were in person, and you all can like meet up. But I don't know if you're all meeting up now or something. But you can use Discord and talk. Last chance to redeem your points, I guess, is today, so just don't forget that. Well, what I mean by that is you should just, within Discord, if you want to ask questions to each other, you can. But just keep everything public. Don't do any shady stuff. I am wearing UNLV shirt to represent. It's not just any t-shirt. I have no clue what I'm teaching outside of the data analytics classes. I maybe 301 if Bergel doesn't teach it again. I don't know. I don't know. Maybe they'll make me do a 202. Maybe not. I have no clue. They don't tell us these things. They don't tell anybody. It's just a staff. Like you'll just get a roulette spun like a week before classes start, and then we'll see. I suspect I'll teach one CS course, but I have no clue what it'll be. But if it is one, it'll be 301, 302, 202. It's not going to be like some new course or something. I presume everything will be online. Just like, actually, I don't know. Maybe some will be in person. But I presume at least the lower level courses will be online. Maybe the higher end courses may be in person, depending on the instructor. We're currently waiting to see if we get accepted for the paper that we published for the AR application. So once we see what happens there, then we'll make a decision on that. The app is pretty much done though, at least for what we wanted. And then yeah, we'll see. We would need more funding though if we want to do more stuff to it. In other words, we're basically out of money. We spent thousands on that, mostly on student pay, but still. Yeah, I think that would be very cool, but we would need somebody dedicated to just mapping out the app and whatnot. So. Maybe, I don't know. I mean, that's how we actually got money for the original app, was through the CARES Act, like the COVID relief funds and whatnot. So maybe, I don't know. Maybe I have to look at if there's any education money going through the infrastructure bill. I got $60,000 basically for ULab's app development and whatnot, of which, you know, a considerable amount of that went to the AR navigation app. Yeah. I think if we had maybe $10,000 more, we could do the full campus. It's just gruesome. Somebody has to sit there and like map the thing out on Unity. We have a map maker, but they still have to fix it once they map it. That's a possibility of open sourcing it. But like I said, our first focus right now is to see if we can get the publication published, because that would bring prestige to UNLV and to the student and to everybody. If that happens, and they want me to open source it, and that's the way it goes, and I will be down with that, because the publication is pretty much worthwhile. I also would think it would be a cool idea to expand to like a commercial setting, potentially for supermarkets and things like that, advertisement, ad revenue, in terms of augmented reality ads and whatnot. So I think it's a cool concept that can be commercialized, but I think it's very hard to commercialize it. I talked to people at the Office of Economic Development on commercialization, and it's not easy, but it could be doable. I just don't know if you have the time, or if it's the right thing to spend the time on. There are opportunities, but they are depending on the instructors. It kind of works out better when you're in the higher level courses and you're taking it with people that are doing that kind of research. Like if you take the machine learning course, and with Fatma, maybe she has a position for research on machine learning. You also want to approach professors that you want to do research with if it interests you what they're doing research on. And it also helps if you have funding for that, so that you can get paid for it, because most people don't want you to work for free. Not because they don't want to exploit you, but because then you don't have a motivation to keep going and you could quit halfway through. So it's like better off for everybody if you're getting paid. So you have to go to the Office of Undergraduate Research and be connected with somebody that you want to do research with. That's what I do with the people that I have for research. Is most of the money there is for minorities, but they will, if you're a minority, then you have a high chance of getting money if you're within one of them. Since UNLV is a minority serving institution, for Hispanic serving institution, and for ANAPSASI, which is like, I'm gonna mess up the name, but it's like Asian, Native American, Pacific Islander, some sort of really long acronym. But if you fall in those categories, then they have special funding for them, because we get special funding from the government because we're a minority serving institution. And so what they do is they apply for that, and then they get like $3,000 at least, which isn't a lot, but it's some money. And then you do the research with the person you want. So if you're interested on that, I can, even if it's not with me, I can give you the link to some of that, and then you can. What you have to do is you have to find someone that's going to basically work with you, and you have to do this ahead of time. Like, it's way too late to do it for spring, but I have 2 students who are doing it for spring actually, and if you're interested in grad school, I think it's a pretty good experience. No, water. It's a waste of points. But yeah, go to that link and then check that out. Especially this one, the second link I'm about to post. This one. That's the one, and let's see if I can get the acronym right. So it's ANAPSASI, and it stands for Asian American and Native American Pacific Islander Serving Institution. I was close, but not quite there. I took a course actually this semester. I got paid $500 to take it. It's kind of cool. It's cool to get paid to go to school, right? So, well, I mean, scholarship, same thing, but you know, and it was a equity course. So, you know, one of the important things is to actually remember these acronyms, but I forgot. But I still passed the course because, you know, C's get degrees, right? So, yeah, and one cool thing I learned, which I will share, is that, you know, because I'm not a Nevada native, so I didn't grow up here, so I didn't go to school here. Because I told people that grew up here, and they said they actually learned it in school, but I didn't because I didn't go here. So they said that UNLV is on. Oof, I'm gonna screw up the name too, but it's Native American land by the. It's three groups. The bigger of the three in terms of population, I think, was the Paiute land, which I thought was cool because I always just came with the assumption that like Nevada was like a desert completely and there was like no survivors because of the desert. But no, there was like people here. That's kind of neat. And apparently, those are the people you can go and buy the fireworks from. So, that's pretty cool. Because then I can go and buy fireworks from them. So it's pretty neat. So, lots of cool things. But yeah, check those links out. And if you apply for any of those, then do it. It's free money, and you get to do some fun stuff. So just find someone to do it with. Okay, well, that's it. So since this is the last time that I'll see you live, I mean, I'll be around for the next. Well, I'll be around for a while, but like I'll be active with this class for until the end of the semester. So just because you don't see me here, it's not like we're just going to disappear. So yeah. Thank you all for coming to this class. I hope that you got a lot of good knowledge out of it. I want to emphasize the fact that unlike other classes in the department, this is one of the classes that I think a lot of things will come from when it comes to like a coding interview. Even if it's as basic as the beginning of the semester stuff, or as fancy as like Dijkstra showing up. So I do encourage you to not forget some of this stuff, or to at least have an easy way to refresh it before you do an interview when you get into that stage. Hopefully that, it's a lot of algorithms that you go through and it's a lot of work, and hopefully, some of that does stick around, but if not, then have a way of quickly referencing it in case you do need that information in the future. And, I wish you all the best, when you go out there into the workforce, or academia, if you go that route. Hopefully this course had a positive impact. I heard like weird sound, but hopefully this course had a positive impact in your education, and that was a pleasant course. COVID and everything, it's not the same as being in person, but at least you get to relax at home watching it. And you can you're not in a room with strangers and not the ability to do things because you're stuck there. So there's good and there's bad. So think of the positives, okay? So if I don't see you again for future courses, then I hope that you all again do really good. You know where to find me, at least online. You never went to my office because there's COVID, but yeah, if you need any help, I can try to give you some help. But yeah, all in all, thank you all for being a fun class. Thank you for being very talkative. I do appreciate that a lot because it's from the instructor side. Otherwise, I have to just speak to the wall. So it does make me feel like I'm actually in a group of people that care and that are actually interested in knowledge, which I do greatly appreciate. So thank you again, everybody. And I'll see you around on campus or online, okay? You're more than welcome to hang around Discord forever if you want. Share your pain with future cohorts and whatnot. So, yeah, best of luck in the exams. Do good. Don't worry too much about it. Just do your best, and I'm sure that you get something good out of that. Okay? All right. Take care, everybody. Thank you all. And good luck. Good luck in the test. All right. See you all later.